Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving deeper into the java.util.concurrent package. We're currently in the Fundamentals of Concurrency season, exploring the introduction to java.util.concurrent chapter. In our previous episodes, we covered the overview, motivation, and concurrency problems solved by this package. Now we're excited to discuss the key interfaces and classes that make up the backbone of Java's concurrency utilities.
That's right, Sheila. This is where we really start to get our hands dirty with the tools Java provides for concurrent programming. It's going to be an exciting episode.
Absolutely, Victor. Before we dive in, let's start with a quick quiz for our listeners. Here's the question. Which interface in java.util.concurrent is responsible for executing submitted tasks using a pool of threads? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of what we'll be discussing today. I'm curious to see how many of our listeners can get this one right. It's not as straightforward as it might seem at first glance.
Now, let's start with the basics. Victor, could you explain what interfaces and classes are in Java and why they're important in the context of concurrent programming?
Certainly, Sheila. In Java, interfaces define a contract of methods that implementing classes must fulfill. They're like a blueprint for behavior. Classes, on the other hand, are the concrete implementations that provide the actual functionality. In concurrent programming, interfaces allow us to work with different implementations interchangeably, while classes give us the specific tools we need to manage concurrent tasks.
That's a great explanation. So if we think of it like a factory, interfaces would be like the job descriptions, and classes would be the actual workers performing those jobs, right?
Exactly, that's a perfect analogy. Now let's start with one of the most fundamental interfaces in java.util.concurrent, the executor interface.
The executor interface sounds important. What does it do and why is it useful?
The executor interface is indeed crucial. It provides a way to decouple task submission from task execution. It has only one method, execute, runnable. This simplicity is powerful because it allows you to submit tasks without worrying about how they'll be run.
That's interesting. So it's like having a manager in our factory who takes tasks and assigns them to workers without us needing to know which worker does what.
Precisely. And building on that, we have the Executor Service interface, which extends Executor and provides more advanced functionality.
What kind of additional functionality does Executor Service offer?
Executor Service adds methods for managing the lifecycle of tasks and the executor itself. It includes methods like submit, which can return a future representing the task's result, shutdown, to stop accepting new tasks, and await termination, to wait for submitted tasks to complete.
That sounds really useful. It seems like it gives us more control over how our concurrent tasks are managed. Are there any common pitfalls when using Executor Service that our listeners should be aware of?
Great question. One common mistake is forgetting to shut down the Executor Service when it's no longer needed. This can lead to your application hanging or resources not being released properly. Always remember to call shutdown when you're done with the Executor Service.
Thanks for that tip, Victor. Now, you mentioned Future earlier. Can you explain what that is and how it relates to Callable?
Certainly. Future represents the result of an asynchronous computation. It's like a promise of a result that will be available at some point in the future. Callable is an interface similar to runnable, but it can return a result and throw checked exceptions. When you submit a callable to an executor service, you get a future in return.
I see. So if runnable is like a worker in our factory analogy, callable would be like a worker who not only performs a task, but also brings back a result.
Exactly right, Sheila. And the future would be like the order slip you get when you're waiting for your meal at a restaurant. It doesn't contain the result yet, but it promises that the result will be ready eventually.
That's a helpful analogy, Victor. Now, let's move on to some concrete classes. Can you tell us about ThreadPoolExecutor?
Certainly. ThreadPoolExecutor is a powerful implementation of the Executor Service interface. It maintains a pool of worker threads and manages a queue of tasks. This class allows you to configure various aspects of the thread pool, such as core pool size, maximum pool size, and keep alive time for excess threads.
That sounds quite flexible. Are there any best practices for configuring a ThreadPoolExecutor?
Good question. One key practice is to choose your thread pool size carefully. Too few threads might not fully utilize your system's resources, while too many can lead to excessive context switching. That's when the CPU spends too much time switching between different tasks. A common rule of thumb is to use a pool size equal to the number of CPU cores plus 1 for CPU-bound tasks, or much larger for I/O-bound tasks.
That's valuable advice, Victor. Now, we're running short on time, but could you briefly mention a couple of other important classes in Java, util.concurrent?
Of course, two other classes worth mentioning are CountDownLatch and CyclicBarrier. CountDownLatch allows one or more threads to wait until a set of operations in other threads completes. CyclicBarrier lets a set of threads wait for each other to reach a common barrier point. These are incredibly useful for coordinating between multiple threads.
Thank you, Victor. Those sound like powerful tools for managing concurrent operations. Now, before we wrap up, let's reveal the answer to our quiz question. The interface responsible for executing submitted tasks using a pool of threads is ExecutorService. Congratulations if you got it right.
Great question and explanation, Sheila. ExecutorService is indeed the key interface for managing a pool of threads and executing tasks concurrently.
Thank you, Victor. To summarize today's episode, we've covered the key interfaces like Executor, ExecutorService, Future, and Callable, as well as important classes like ThreadPoolExecutor, CountDownLatch, and CyclicBarrier. We've learned how these tools work together to manage concurrent tasks efficiently and flexibly.
Absolutely, Sheila. Understanding these interfaces and classes is crucial for writing effective concurrent code in Java.
In our next episode, we'll be wrapping up our chapter on Introduction to Java.util.concurrent with a comprehensive summary. Stay tuned for that. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue producing this content. Until next time, happy coding.